Institute. So today we'll be starting off with the front-end training demo session. Okay, we can also call it as pre-synthesis flow training. This will be the agenda for training today's session. We'll just start off with understanding what is the schedule for demo session. I mean, what all things we'll be doing as part of the demo session. Then we'll be talking about just a basic institute overview, what are the courses offered, and before that we'll also talk about what is VLSI flow is about. I mean, just to give you a brief about like where does front-end domain, where does the functional verification domain come in the flow. Right? Then we'll talk about how do you choose a right course, the course overview, the facilities, institute facilities, and then we'll talk about the placements, and then we'll go into a little bit of technical. I mean, most of you are here for functional verification training, so we'll just give a brief about what is functional verification kind of. So this would be the agenda. So today's demo session, I mean, what basically this demo session is for multiple courses. So what all courses is it covering? So it is covering RTL design and functional verification. See, whether you call RTL design and functional verification, whether you call front-end training for freshers, whether you call functional verification training for freshers, or whether you call ASIC verification, all four terms are same. Right? Sometimes people call, I want functional verification training. Sometimes people say I need RTL design and verification. Both are referring to same course. And other than that, today we are also starting the course for experienced engineers also. I mean, see, sometimes there are working professionals who needs to gain more exposure to what they're doing. So they also join. So the functional verification for freshers, and we are also starting functional verification for experienced engineers. Other than that, we are also starting today Verilog for design and verification, system Verilog for functional verification. So now you may ask, is it possible to offer so many courses? See, when you say Verilog and functional, both are same. I mean, same in sense, Verilog is a part of functional verification. So let's say there is a third year student or a student in fourth year BTech. He won't have time to do a 6 months of functional verification, but he wants to do only Verilog. So we offer that individual courses also. Other than that, today we are starting FPGA design and verification. What is FPGA? I'll just talk about that briefly in a few minutes. Okay. Other than that, we are also starting RTL design and integration. It is another aspect. We'll discuss where does the RTL design integration comes into the flow. It is mostly meant for working professionals. Then we are also starting DFT, design for testability. Okay, so these are all the things which the demo session is targeted for. So all these courses will be starting from Wednesday, that is from 25th of this month it will be starting. That means today, now we are starting. For next 3 days we'll be taking a break for completing the course enrollments. Then we'll be starting off with the session from Wednesday onwards. Once we start from Wednesday onwards, the course will be continuous. Okay. So what is the front-end demo session schedule? It is from 9:30 a.m. to 12:30 p.m. 3 hours. Now you may say, what about DFT? What about FPGA? Generally, for other domains, there will be a different schedule. Like for DFT demo session, you can attend from 9:30 a.m. to 11 a.m. Like you can attend the morning session. It like today's session is more like a overall course overview, a little bit of front-end domain, but it will be useful for DFT people also who are interested in DFT. Regarding the schedule for core DFT training, I'll inform you. I mean, it was something for previous demo session we had scheduled at 3:30. We will send out an email with the exact schedule, or during the break, I'll check with the admin and I'll inform the schedule for DFT demo session. See, some of you might be joining for these things. So for all of you, this would be the demo session. Those who are joined for DFT, this I will inform you. Okay, during the break, I'll inform you what is the schedule after confirming with the admin. Now, regarding FPGA, if there is someone, or regarding RTL design integration, if there is someone, please let me know. We'll inform the schedule accordingly. Okay. Now, Just about myself. Okay, my name is Srinivas, and I'm the founder of the institute. I have done my dual degree from IIT Madras, and I have around close to 10 years of teaching experience. I've been teaching since 2012, and I would have trained close to 2,500. I mean, it's kind of old, which has gone here. Around 2,500 plus students I would have trained in various domains, and I have close to 14 years of working experience, and I am also associated with mentor graphics. I do corporate training to almost 20 25 companies I have done in last 1 year itself. I mean, I have wider exposure to the complete front end domain. Okay. And now let us start off with let's get into the today's session. Let's start off with understanding electronic systems. A very brief about electronic systems, because people at times confuse between what is VLSI, what is embedded systems, and then what is application, what is software, right? Let's try to connect all of them. Okay, so let's try to understand what is exactly an electronic system. Let's start off with understanding what goes into mobile phone. Let's say if you see your mobile phone that you are using, what do you see from the mobile phone basically? Can someone tell me? Let's say in mobile phone, if I give you mobile phone, what do you see in the mobile phone? Display. If let's say we open the mobile phone, what do you see now? Some circuit you see, some board you see,
Processor.
then some chips. What else do you see? Battery
Microphone,
you may
speaker,
see, right? So in summary, what all things do you see? uh, these things.
camera.
I mean, if you, this is how the mobile phone looks like outside, but if you open up, it'll have some flash for camera, antenna, some satellite DMB tuner, some chips will be there, right? Modern chipset, volume button, different things will be there. That's what collectively makes up the mobile hardware, right? This is what you see, but there is things which you don't see also. I mean, which you can't see, right? So what exactly is it? What are things that make up a mobile phone? When I say mobile phone, just if I give you this mobile hardware, will it work without anything? It won't work, right? If I just give you a piece of hardware without anything inside it, will it work? What do you mean by without anything? Without an operating system, without the drivers, will it work? No, right? It requires everything. That is what makes up the electronic system. So what all things make up a mobile phone? Very first level, you say that chips, processors, screen, USB port, camera, sensors, audio, speaker. We collectively call all of them as what? Hardware. Then what is that you don't see? These are the things. They, these are the things which we see, but there are things which we don't see. What are those things? Operating system you don't see. It's installed, but we don't even feel that it's there. But without operating system, it won't work. Then what else? You have firmware. Like what is firmware? Something like drivers, USB drivers, PCI drivers, camera drivers, various drivers will be there. Without that, because of that only, my phone works. If there are no drivers, the phone doesn't work. Then you have applications. What is an application? You tell me an example of application. WhatsApp is an application. Google Pay is an application. Any SMS, that window itself is an application, right? Everything is True Color is an application, right? There could be 100 applications in your mobile phone. That is what collectively makes it the electronic system, right? Overall. So, uh, so mobile. In summary, what is that? Mobile phone has four layers that make it up. What are the four layers at very basic level? What is present? Hardware. At very basic level, hardware is present. What is that? Processors, camera, and sensors. I mean, I'm just giving you an example. Okay, it is not the only hardware. There could be 100 things that make up the hardware. In fact, our discussion is going to be about hardware only today, right? Who develops hardware? What is who? I mean, the person who develops this hardware, what we call him? The person who develops hardware, we call him as hardware engineer. In short, we call him as VLSI engineer. Now, when you say VLSI, so the person who develops the hardware is called as VLSI engineer. Now, the hardware engineer itself could be multiple domains. PCB engineer. Even a person who develops printed circuit boards is a hardware engineer. Even the I worked in the industry in VLSI. I am also a hardware engineer, but my classification is VLSI engineer. The person who works into printed circuit boards is a PCB engineer. Okay. Next, what is the next layer after hardware? No, just above hardware, what you have? Drivers. Okay, you have firmware, that's called as firmware, nothing but drivers. Driver, don't confuse with the bus driver or anything. No, I'm just telling you because see, as a fresher, it's very easy to get confused, right? I mean, even if I was in your level, I would have confused. What is driver? I mean, is it like some bus driver? Is it auto driver? Right? It's not the driver. Driver means what is driver role in the real life? The bus, what is the role of a driver? He drives, he controls the flow of the bus and everything, right? See, there is a hardware, like vehicle is like a hardware, car is a hardware. Without driver, car don't have any meaning. Do you agree with that? Without driver, car itself won't drive, except for automated, fully automated cars, they won't drive itself. It is the driver who sits and gives the directions, then it drives. The same, that's what firmware engineer also does. He develops the drivers which tells what hardware should do. Exactly same. That's why the name driver. Otherwise, they would have given conductor. If it was to, it was doing something else, they would have given name conductor or something else, right? No, right? Why they have given the name driver? It drives how hardware should behave. So that is above the hardware. How it is developed using C language, C++ language, they develop the drivers. Who develops this firmware? What is that person is called as? Firmware engineer. Or in a very generic sense, what is it called as? Embedded system engineer. You understand the difference between what is VLSI and what is embedded system? VLSI engineer makes the hardware. Embedded system engineer uses that hardware and develops the drivers which will work, which will tell how the hardware should behave. How to use the hardware, when it should transfer, when it should stop transfer, when it should turn on, all that decision making embedded system engineer does. Who is above firmware? Next, operating system. Without operating system, can you have applications? All right. What is the next layer? Operating system, which is Android OS, iOS, Windows, Linux. These are all operating systems, right? Then who develops operating system? Software engineer, right? I mean, if you go to Microsoft, the person who works in Microsoft and who develops operating system, what we call as? We don't call him as operating system engineer. We call rather a software engineer. So it's a software engineer. They may have some generic, very detailed terms, but for a person who is outside, he is a software engineer. Who is after operating system? What is above operating system? Applications, right? Once you have an operating system, you install apps. Like you go to Play Store, you download and you install. What is an example? Like GPay, like someone said, WhatsApp. These are all applications. Now, who develops applications? It could be software engineer. Even I can develop. I don't need to be a software engineer. I can call as an app developer, right? Anyone. I don't need to be a software engineer. I can still develop. So it could be software engineer. It could be application developers. In summary, all these four layers are essential for electronic device to work. If something is not there, it won't work. Let's say you ask, I won't have hardware, but I have drivers, I have the operating system, and I have the application. Will it work? No, right? I have a driver, but I don't have a car. Will the car go? No, right? Same is what happens in electronics also. Everything is required, right? Now everyone plays their own important role. Nothing like VLS engineer is important. Nothing like software engineer is important. Everyone has their own role. Okay. Have you understood what exactly constitutes an electronic system? Next. Now, because we are into VLSI, let's talk about VLSI only. Because you are all coming for a VLSI demo session, let's only talk about VLSI. Now, embedded is also an interesting domain. I mean, the people who they have to understand what is the hardware, what all things are present inside the hardware, and they need to develop some programs which will work on the hardware. That's called as embedded systems. Why it's called as embedded system? It is getting embedded with the hardware. It's a system which is getting embedded with the hardware. That's why it's called as embedded systems. Next, let me just. Okay, let's talk about VLSI. What does VLSI stand for? Very large scale integration. Okay, so before we go ahead, those attending online, is my audio quality good? Are you facing any disturbance in the session?
No, sir.
Clear
No,
only.
It's
sir.
clear.
Sir, good, sir.
Thank you. So what exactly VLSI stands for? Very large scale integration. Now, what do you understand from that term? You're trying to integrate things in a very large scale, right? What exactly are you integrating? Can you tell me? Integrating means, like, I'll give you an example. We have a house. How did the house become? By integrating bricks. How many bricks would have gone? I said, you imagine this house, this building, how many bricks would have gone? Roughly thousands of bricks would have gone, right? After putting in thousands of bricks, the house looks like this. In VLSI, what is that basic unit? Like for a house, basic unit is what? Bricks. For a VLSI, what is the basic unit? Transistors. By putting together transistors, they come up with a chip. So how many transistors they put? Let's say we talk about mobile phone that you are using. How many transistors do you think make up that chip? Tell me. Any rough guess? I want session to be interactive.
Lakhs
Millions
of
of transistors.
Billion is how much? Tell me. In crores, how much
10,
is it?
10 lakhs.
10. 100 crores. 1 billion is how much? 100 crores. So 100 crores of transistors goes into small chip. If you open, you remember in the first slide I shown you small chips like this. The whole board was there. In that I shown you small chip. Into this, how many transistors are going? 100 crore transistors are going. That's why VLSI is so complex. Okay. Now we'll discuss why we need so many transistors and all that we'll discuss. But have you got a basic idea about what is VLSI? Putting together, integrating all those transistors to achieve some functionality. Right? For example, I have a before the house was made, there were only some thousands of bricks somewhere. Only I brought all of them and I placed them in a proper order. My house became. If I just throw them somewhere randomly, will it become house? All right. So that is what VLS engineer does. The role of VLS engineer is to make sure that the things are planned in such a way that it does something meaningful. What is meant by meaningful? It works as a mobile phone, or it works as a laptop. It works as a switch. It could be anything. Right? That flow is called as VLSI design flow. What is VLSI design flow? The flow that goes into developing the chip is VLSI design flow. Can I call developing of drivers as a VLSI flow? Like whatever embedded system engineer does, can I call his role as a VLSI? No, right? Because he's by the time he starts, already chip is developed. So he doesn't have anything to do with the VLSI. Developing of the hardware, he doesn't have anything to do with it. So what are we integrating? Transistors. Can you tell me different types of transistors?
BJT,
P and N
FET.
type is the
Okay.
extrinsic semiconductor, right? We have after doping you get P and N. What are the types of transistors? BJT,
PNP, BJT, FET,
MOSFET, PMOS and
MOSFET.
NMOS. Okay, you said P and N. Okay, PMOS and NMOS. Then what else? CMOS, complementary MOS. Then you have what? FinFET. So these are the different technologies. Currently, what is being used? FinFET is used. Before that, we were using CMOS. Before that, we were using BJT. Because FinFET is the most efficient transistor that is available now. What is efficient is area wise, the performance wise, the power consumption wise, in every respect, FinFET is the most efficient. That's why we are using it. There are two major styles of developing the VLSI chips. There are two major styles in which VLSI chips can be manufactured. What are the two major styles? Can you tell me? ASIC.
Frontend.
ASIC stands for what? Application Specific Integrated Circuits.
RISC.
What is the other one? FPGA. What does FPGA stand for? Field
Programmable
Gate
gate
Array.
array.
Next, what is ASIC? What is FPGA? Let us talk in the next slide. because it is important for you. It is important for you because many times people don't even know that there are opportunities in FPGA and they just get into ASIC. So it is important for you to know what is there in each domain and accordingly choose a right domain. Let's try to understand ASIC versus FPGA. How do we figure out? I mean, like I told you that what is ASIC means what? Application specific integrated circuit means what? The flow is such that they target one chip only. The flow. I will give you example in the real life. Let's say uh, there are two ways in which houses can be constructed. Okay, one is you start everything from scratch, you purchase a land, then you construct, and finally you have the house. You go through this flow. This would be an example of application specific integrated circuit. Okay. The second example is I will rather give you a better example. Okay, let's say government of Karnataka, okay, wanted to construct 1,000 houses and give it to the poor people. That's what government of Karnataka wanted to do. Okay, there are two styles in which they can develop the houses. They have a land, of course. They have a land. So what is the first thing they will do? They construct each and every house using the bricks, okay, in their own style. That is one style. Second, what they do is they go for containers. See, sometimes you might have seen container homes, right? Like they are called as prefabricated houses. What they do, they purchase the container, they just modify it as per their requirements. In the first case, what we are doing everything from the scratch. We are preparing the ground, right? Then we are planning the foundation, then we are constructing the walls, we are putting the slab, everything we are doing. That kind of entire flow is what we call as application specific circuit. In that case, what is that, how that is being targeted for? That is being targeted to work like a house only. Now, whereas when I go to the third person who is selling me the prefabricated containers, the same container can be used as a house, the same container can be used as an office room, same container can be used for some other utility purpose. You may want to keep a shop in that. But the one which government of Karnataka has developed in this, by following this, is only meant to work as a house only. Now tell me which one they will go for. They most probably will go for this one. There is a decision making they have to do. In both the cases it will work. Here also it's a house, here also it's a house. But here the thing is, this container could have been used for anything. It could have been used for house, it could have been used for office, it could have been used for a shop. You agree with this, right? So that is the kind of difference between ASIC and FPGA. In ASIC, what we do is, our purpose itself is to construct this building. Whatever I do, my flow is targeted only for developing this house. In FPGA, what happens is I get the boards already. Now the same board I can use as a house. I mean, I can use it as a mobile phone. I can implement in such a way that it behaves like a mobile phone. Same board I can implement it in such a way that it behaves like a laptop chip. Same board I can implement as if it is behaves like a router. There will be different types of FPGA boards. So because see, laptop is different from mobile is different from router is different from different electronic device. So the same board cannot work, right? They will have different variations of the boards. But the basic concept is what? You already have the thing fabricated. On that you implement what you want. That is called as what? Field programmable. Why the term field programmable coming into picture? Field means what? Not the football field or anything. It is a circuit which is already there. You program it to behave what you want. It's like a gate array. Gate array means what? What is gate here? Logic gates, AND gate, OR gate. If I have thousands of gate, how do I call that? This as gate array. I cannot call gate thousands. I cannot call gate lakhs. I cannot call gate crores. What is that in short called as gate array? I can program how it should behave, and then finally it gives me the required circuit behavior. That's why it's called as what? Field programmable gate array. What about ASIC? ASIC is developed specific to the application. I want mobile phone, that will only work like a mobile phone. It will not work like a laptop. It will not work like a router. If I have to develop a router, I have to go through another dedicated flow. Did you understood difference between ASIC and FPGA? Now the question comes, why do people work more in ASIC? Why do people less work in FPGA? Generally, 85% of work happens into ASIC. 80 to 85%. Around 15 to 20% work happens into FPGA. Let's try to understand the difference between ASIC and FPGA in terms of the cost. Okay, cost of making ASIC. If you have to make an ASIC, the mobile phone that is there in your hand, the flow, let's say you go to Qualcomm, they are working on developing that chip that went into your mobile phone. One of the examples, right? They would have spent multi-million dollars to implement that flow. But once you have implemented that flow, making each chip doesn't make much cost. Flow is very costly, but once you have made it, each chip can be manufactured in $20, $30 or $10 based on what is the die area. But coming to that stage where you manufacture that small chip is very costly. That process, right, is very costly. Whereas, what is the cost of making FPGA? Tell me. I want you to implement one design on FPGA. What is the cost? How much it will tell me roughly. You can tell me any number, doesn't matter. Few $100s. Few $100 means what? Why we are talking in dollars? All these terminologies are generally talked in dollars. We can talk in INR, but dollars is what makes sense in this case. Okay, so few $100 means what? $100 is how much? 8,000 rupees, right? So what do you get in 8,000 rupees? You can go and purchase some FPGA board. Maybe if you put another few more $100, you can get a complex FPGA board. That complex FPGA board, you can develop what you want. Right? Then why people go for ASIC? You understand, right? If which one is costly and which one is cheaper? ASIC is costly and FPGA is cheaper. So at very first look, what makes sense to you? I mean, what do you think people should be using always? FPGA, right? But the problem with FPGA is this diagram explains. Till specific number of units, say there is a breakpoint, till that specific point, FPGAs are, this is number of units, this is the total cost, this is total cost, this is number of units. Till one point, let's say you are manufacturing one unit, only your idea was to manufacture only one unit. In FPGA, it costs only $100. In FPGA, how much it will cost? $100 only. In ASIC, it will cost you minimum of $5 million plus $15. Now, you may ask, how did you come up with 15? Just a hypothetical case. Okay, it could have been 20, 25, 5, anything. Let's say 1 million, 5 million plus $15. Now, let's say you wanted to make 100 chips somewhere here. What would be the cost of FPGA? There is no fixed cost in FPGA because you just have to purchase the board, that's all. How much will be that? $10,000, right? Because 100 into 100 is how much? 10,000, 10K. What about ASIC at this point? What would be the ASIC cost? Tell me. Simply you have to tell me, for each chip it will cost you $15. To make 100 chips, how much it costs? 1,500. So 5 million, still it comes to what? 5 million plus $1,500. Now, like that, as you keep going, you will reach a point where FPGA starts getting more costly compared to ASIC. Even you can sit and do that calculation. Let us do that calculation also, because so that you understand what is FPGA, what is ASIC, and it doesn't take much effort. So how do I do that? 5 million is what? 550 lakhs plus n into 15 equal to n into 100. So what is it? 85n equal to 5 millions. Got it right? So n is what? 8 million divided by 85. You got it? So what do I have to do now? Take calculator. What is 5 million? 50000 divided by 85. How much it comes to? 59,000 something. You understood what is the calculation I have done? Are you getting? See, 5 million is the fixed cost. You cannot do anything about it. N15 is what? N into 15. Number of chips into 15. That equals to what? N into 100. Because in FPGA, whatever number of chips you have to make, that into 100. There is no fixed cost. So what does N come to? 59,000. 58,823. That means what? Once you cross 59,000 mark, ASIC becomes more cheaper. FPGA becomes costlier. Now, the mobile phone that you are using, tell me how many mobile phones like that would have got manufactured? The mobile phone that you are using, how many mobile phones would have got manufactured throughout the world? At least 5 lakhs, at least 10 lakhs, right? At least 5 lakhs would have got manufactured. Tell me, should they use ASIC or should they use FPGA? ASIC only, right? Because once you cross in our calculation, once you cross 59,000, ASIC makes sense. Now, had fixed cost been 10 lakhs, let's say $10 million, then it would have gone to 1,10,000. The basic unit, the minimum cutoff, minimum break even. What I'm telling, see, the fixed cost was 5 million. That is where it went here. What about had it been 10 million? It won't be same number. It would have gone to something like 1,10,000. It would have gone to, because this number will increase, right? It will double, right? Automatically. That would go to 1,16,000 or 17,000. Accordingly, they make a decision. Okay. I'll give you an example where FPGAs will be required. Where do you think FPGA will be required? Where you know that there is no need for bulk production. Mobile phone, does it require bulk production or less production? Bulk production, right? Tell me an example where you don't require bulk production. You are in BTech college, right? You use oscilloscope. Do you use in your house, in your kitchen, do you have oscilloscope? Or in your living room, you keep oscilloscope? No, right? You go to some government office, will they keep oscilloscope? No, right? They won't keep. Where oscilloscope is required? Only in colleges that are also good colleges, right? They will keep only oscilloscope. So that means what? How many colleges will be there in India? Few thousands. In world, multiple thousands. Now tell me how many oscilloscopes are required? Few thousands only, right? So in that case, tell me what makes sense to manufacture ASIC or FPGA? FPGA, right? So that's how they make a decision. Okay. Now, till one point, always FPGA makes sense. That is this graph. You can see here. FPGA is pure flat linear, starting from this. ASIC is till this point fixed cost is there, but the rate of each, manufacturing each chip is very less. Now, when you go somewhere here, this would have been so much. This would have been only this much. So the difference will be this much. Have you understood what is ASIC and what is FPGA? Which companies go for ASIC based production? The one which we need, uh, bulk production, mass production. Okay. Now you need to just use your common sense. and ask yourself which one requires bulk production. Laptop, bulk production, right? So what is the technology? ASIC, right? Defense, let's say India is the Indian defense, DRDO is manufacturing some Tejas or some missiles, right? They will also have chips actually inside it. Will they go for FPGA or ASIC? FPGA. Why? They won't make 1 lakh missiles, right? Unless you want to destroy 10 worlds, you don't go for so many, you need only thousands. So which technology they'll use? FPGA. So any defense company, if you take, what is that they will take? What is that they will do? FPGA. Now tell me, does electronic production only happens in India or worldwide? Worldwide, right? Does defense companies only in India or everywhere? Everywhere, right? Now if you go to France, there is a defense company. Which technology do you think they will use? FPGA only, right? Because even if they produce for remaining 20 countries, let's say they sell to India also, they may sell to some other country also, but still their manufacturing will be very much within thousands only, right? So tell me which technology? FPGA. Okay, because for them it is cost effective. Had they been making lakh, or not lakh, maybe million this chips, right? Million missiles, they would have definitely gone for ASIC. Okay. So because of that, you see a lot of things we use in today's world is bulk mass produced ones. Except for colleges or defense thing, do people use defense products mass? No, right? Except for that, everything that you use mass produced, like routers. These days, almost a lot of people in the cities will have, even in the villages, you will find those who need internet, mobile phone, laptops. Laptop is also mass production. See how a laptop works, I'll tell you. You have a Lenovo brand, there could be another HP brand. All of them have a same common chip going. It's it's the drivers and the applications which are differing, but otherwise the common thing, the basic hardware is same. So in that's why 85% of the companies work into ASIC. It could be different, 80 to 85%. I'm talking about India. Okay, how much percentage of companies work into FPGA based production? 15%. So in India I'm talking. Okay, if you go to world, if you take as an overall world, 75% into ASIC, 25% into FPGA. So there could be variation. Now you may say, where is that number 25? Where is that number 70? Can it be told like that? No, right? It's a rough number, 70 to 80% or 20 to 30%. But the point you need to remember is what? There are companies who work into FPGA. There are a lot of companies who work into ASIC also. Now, why this is important? Because you need to know that there is a domain called as FPGA. Because you hear only physical design, because you hear only design verification, that's not the only job. There are opportunities outside of what you see and what you listen also. Okay. Now let us try to understand the ASIC flow design analogy. Okay, ASIC design flow, please don't read this. ASIC flow design flow is similar to house construction flow. Okay, like requirements. First, how do you start house construction? You start off with the requirements, right? Once you have a requirement, whom do you go to? Like I'm constructing a house now. First, what did I do? Do I start putting the whole structure immediately? What do I do? First, I list down my requirements. Then taking the requirements, whom do I go to? Tell me, whom do I go to? Will I go to my neighbor and tell me this is the house I want to construct, give me, help me? What will I do? I'll go to architect. First, I list down what kind of house I need. Then whom do I go to? I go to the house architect. What house architect will take? He will ask me, what is your requirements? Okay. Inputs for him is what? Requirements. What is output? What he gives as an output? He'll give the architecture diagram. What else does he give? Everything: beam structure, plinth structure, column structures, slab structures, the electrical diagrams, the plumbing diagram, everything he will give, right? Architecture diagram, various plans he will give. Once you have the plan, whom do you go to? You go to the contractor or a masonry, saying that this is what I want to construct, help me, right? So what he will take as an input? Architecture diagram, and whatever you got from the architect, that become input to the next person. See, this requirement become inputs to next person. This becomes input to the next person, right? What does Mesri do? Contractor Mesri will do. He will construct the house. He will give you the building structure, right? Now, is it done? Not yet done, right? He has only constructed the walls and the floor slabs and everything. Still, what else do you think is pending? Plumbing is pending. What else? Electrical work is pending. What else is pending? Carpenter work, painting, this putting the tiles. Lot of work is pending. This whole flow is what makes the house construction. Can you tell me who is important here? Everyone is important, but relatively more important is architect. If he goes wrong, everything went wrong, right? Let's say, what is mean by going wrong? Let's say you see buildings falling, right? Why do they fall? Because painting is not done properly. Do you think they'll fall? Why do you think they will fall? Because he didn't put the proper that metal dimensions, right? The steel rod dimensions and other things, the size of the metal and everything, you wouldn't have put in a proper manner to reduce the cost. You would have put a low cost, low this thing, uh, not quality, the low size, like instead of 10 mm you would have given 8 mm structures, those things, right? That's why this person is important, of course, right? But then everyone has, after that, everyone has equal importance, right? So how many people are involved in this flow? Roughly how many categories of people are involved? Around 7-8 categories of people involved. If I go to someone else, they will say no, 10 people are involved, because he will say someone else is also involved. You missed person who puts the tiles. Then you go to someone else, he will tell you have missed interior designer. You go to someone else, he will tell you miss someone else. That means the number of people who work is not any fixed thing. It can vary. But I can say around 10 to 15 categories of people are involved by the time house is constructed. Okay, you got it, right? Now, let us now, with this analogy, after understanding this analogy, let us now get into ASIC flow only directly. Okay. So where does it start with? Where does the ASIC flow starts with? You just take house construction as the analogy. Where do you think how ASIC design flow starts with? Requirements only, right? First, the company, let's say Qualcomm or Intel, wants to make a chip. What is the input for them? Requirements, right? They need to have a requirement. What is that we want to make? It consists of, ASIC design flow consists of 12 to 15 steps depending upon how we divide the activity. Like I said, in house construction, it could be 10 activities, it could be 12, based on how you look at it. Okay. ASIC flow starts, there are two domains in ASIC flow majorly. One is called as front-end domain, one is called as back-end domain. We'll talk about both of them. First, it starts with what? Design requirements. What is design requirements mean? What kind of electronic device you want? Let's say mobile phone. What should be the processor frequency? What should be the USB? Should it be USB 3? Should it be USB 4? What kind of display do you want? What kind of touch screen do you want? All those things are hardware requirements. Now, what kind of operating system do you want? Does it become a hardware requirement? No, right? That is a software requirement. So hardware is different, software is different. After design requirement, whom do you go to? Architect. What he will give you? He will give you architecture diagram, right? Architecture, and he will give you specifications. Then whom do you go to? What do you do? RTL coding. This is done using a language called as Verilog. Using Verilog, we do RTL coding. Then after that, whatever you have coded, you need to integrate it. That is called as what? RTL integration. So what is the first step? Requirements. What is the next step? Architecture. What is the next step? RTL coding. What is the next step? Integration. Integration, it's a common sense. Like you have various things being developed. You integrate everything to make a big chip. That's called as what? RTL integration. After RTL integration, what is the next step? Functional verification. We check whether whatever coding we have done, RTL design coding we have done, is it working fine? That's called as functional verification. Now, what exactly is RTL? What does RTL stand for? Register transfer level. It is one style of developing the Verilog code. After functional verification, we do something called as DFT, design for testability at RTL level. Once it is done, this completes the front-end domain flow. What is the next step after front-end domain flow? Back-end domain flow. What constitutes a back-end domain flow? It starts with some important step called as synthesis. What does synthesis does? It converts RTL to gate level. A synthesis, during the synthesis, whatever you have developed in RTL level, that will be converted into gate level. What do you mean by gate? AND gate, OR gate, XOR gate, XNOR gate, multiplexer, those kind of gates. There is a tools which will automatically do. You give a Verilog code, it will give you the gates. Once synthesis is done, what is the next step? DFT. See, DFT is being done at RTL level also. DFT is being done at the gate level also. What is DFT stands for? Design for testability. I'll talk about DFT in few minutes later. Then what is the next step after DFT? Physical design. What is physical design? It's like you have already, now you have created the gates. How many gates we discussed roughly? How many transistors we discussed? Billion transistors. Gates will be somewhere in the billions, I mean less than billion, because one gate is like multiple transistors. It could be multi-million transistors we are talking about. Gate, what is, how many gates will be there? Somewhere close to billion. Those many gates you are trying to place into 1 centimeter. 1 centimeter. What is 1 centimeter into 1 centimeter? That area is how much? 1 square centimeter. In 1 square centimeter, you are trying to place how many gates? 100 crore gates. Gates will be less actually, maybe half or 1/3, but some, if not 100 crore, we are trying to place 50,000 gates, right? 50 crore gates we are trying to place. Do you think is it easy to do? Challenging, right? Because imagine a table. You have a table in front of you. You are trying to place 10 items in it. One laptop, different things. You will get confused, right? Where should I keep my laptop? Where should I keep my pen holder? Different things. Can I keep my, let's say I am sitting here, can I keep my laptop here? No, right? You need to think all that. That is about placing 10 things. What about placing 50 crore things? There will be challenges, right? So that's why each domain is challenging. Not like functional verification is challenging, not like physical design is challenging. Everything has its own challenges. Once physical design is done, what is the next step? STA. Next step is what? STA stands for static timing analysis. You will hear terms like setup time, hold time. To make sure that there are no setup time violations, there are no hold time violations in the chip. Anywhere in the chip, there should not be any timing violations. That role is called as STA. What exactly we do in STA, we will not discuss. We will discuss during the main training. But to make sure that there are no timing violations, it is very important. If timing violations happens, your mobile phone won't work. Out in your mobile phone, even if at any point of time timing violation happens, your mobile phone stops working immediately. They have to make sure that chip will not have any timing violations once it is fabricated. Then you have custom layout. Custom layout means draw the layout at the transistor level. Till this point, it was all gates. Then that need to be converted into what? Transistor level. That is called as what? Custom layout. Once it is done, you do something called as physical verification. What is physical verification? Is checking the basic rules. See, between, let's say, I will give you simple example. You see outside, you go electric poles. Do you see? Do you see the copper wires, right? That aluminum or copper wires. What will be the minimum distance between those two copper wires? I think it won't be copper, aluminum or steel and iron wires. What would be the distance? Maybe at least they'll keep 1 feet, at least 1 feet. What happens if they keep only 1 centimeter? Shorts can happen, right? Easily due to the wind flow, shorts can happen. So like if I ask, once they have put the lines, someone will come and inspect whether has it been done properly or not. Because once they have put the cables throughout and they have kept only 1 centimeter gap between each wire, do you think is it easy to redo it? Very difficult, right? So they have to check all those things. In chip also, same thing is happening, but at a very small level. See, the gap between wires should be some minimum gap should be there, because even inside the chip, copper wires are there. Whatever chip if you open, what you see is a copper wires only, transistors and copper wires. The billions of transistors connected to each other through copper wires. That's how you can summarize a chip. When there are copper wires, there need to be some rules, right? You have to follow. The gap should be this much. This how the termination should happen. Like for example, you take the pole. This is the pole. They will keep some kind of ceramic material here. Do you remember? If they don't keep, what will happen? The electricity will flow here, and you are walking here, you will feel the shock. Possible, right? So similar thing. I'm not telling same thing. Similar guidelines they have to do in the chip also, but at very nanometer level or micrometer level. So to check whether all those things have been done or not is called as physical verification. Now, as I said, everything is important, but again, who is more important? Tell me. Architecture. Always architecture is most important. Once this is done, what is the next step? There is something called as GDS2 extraction. Once they have come up with the entire plan, once they have drawn everything, they extract some file called as GDS2. The file name, like what is the file name that you play songs and movies? MP4 or MP3, MP4, right? Like that. For chips, there is a format called as GDS2, like .c, .c++. The format of that file itself is called as GDS2. GDS2 will tell where should be the doping, where should be the metal, where should be the polysilicon. Like that, it will tell you everything in a three-dimensional manner. That file is given to whom? Foundries. What are the 2-3 major foundries in the world? TSMC,
Yes.
Shanghai, one SHMC or something, SSMC or something is there, right? One Israel-based foundry is there, Netherlands-based foundries are there, and they are planning to set up a foundry in India also, right? So all what do they take as an input? What file do they take as an input? Once they take, they manufacture something called as wafer. Wafer will look like a big plate in your house. They cut. This is a chip. Once they make that wafer, they may have around 100 to 500 chips per wafer. Whatever flow we discussed, is this FPGA flow or ASIC flow? This is ASIC flow. It is not. It is till this point, ASIC and FPGA are same. Here, from here onwards, FPGA differs. Till this point, there is no difference. Both are exactly same. Till this point, ASIC and FPGA are exactly same, because in both the cases, they need to know requirements, architecture, RTL coding, everything has to be same, right? Once GDS2 extraction is done, what is the next step? Once you get the chips, you need to validate whether the chip is working fine or not. Because without knowing whether chip is working or not, you put it into the mobile phone. What will happen? Mobile phone will not work properly. You need to validate whether the chip is working fine or not. That is called as what? Post silicon validation. What is the next step after that? It goes for the packaging. What is mean by packaging? You put together everything, you solder, like chip. Just if I drop the chip into the mobile phone, will it work? No, right? You need to put it onto the circuit board, you need to do the soldering at a very low level, and then only the whole thing works. Okay, so how does, after packaging, how does the product look like? So by the time it comes to your hand, this is how it is still not done. They now have to put the drivers, now they have to install the operating system, and finally what you have is this. So talking about it, VLSI front-end domain flow. See this front. Do you understand what is front-end domain flow? What is back-end domain flow? Everything till you develop the code and you check the code is working. You develop the Verilog code, like C language is there. There is a Verilog language. You develop Verilog code and you check that Verilog code is working fine. That is all called as front-end domain. Everything after that, starting from that code till you manufacture, till you have this packaging, everything is called as what? Backend domain. Now, VLSI front-end domain is similar to software domain, right? Like what people do in software domain, it is same, almost the same thing they do. What is the skill set of a software engineer? Coding, right? What is that he learns? C, C++ and Java. What else does he do? Just learning language is sufficient? Tell me. Languages, you say. Libraries. Other than that, he needs to understand the requirements. Understanding requirement, what does he do? He develops the algorithms and implement those algorithms using C, C++ and Java. Can I summarize a software engineer like that? Sorry. Can we summarize a software engineer in this manner? VLSI engineer also does something similar to this one. VLSI front-end domain engineer, the first thing he learns is like C, Verilog. Like C++, SV. Like Java, again, as I said, is it sufficient to learn the languages only? No, right? Like in software, they had to learn algorithm, they had to understand the requirement, then they need to implement the algorithms using these languages. In VLSI also, people should be able to read the required specifications. I mean, there will be document which will tell how the chip is going to behave, how the chip should behave. That is called as specifications. Understand the implement these specifications and requirements using various protocols. What kind of protocols we are talking about? USB, PCI Express, DDR, SPI, AXI, AHP. There will be many protocols. Okay, you got right. What is how software and VLSI domain are kind of related, is similar to each other. Okay. Software doesn't involve backend flow. What do you mean by that? In software, they don't manufacture the software. Once you develop the software, what they do, they put it on, they install the software into the electronic device. Let's say there is a banking application developed, they will directly go and install it into the laptop and it starts working. They don't have to manufacture the software into any chip. Whereas in VLSI, we need to manufacture. See, once this code has been developed, once the code has been developed, you cannot use that. Let's say you go to mobile shop and you say, I want to purchase a mobile. He won't give you Verilog RTL code. Will he give Verilog RTL code and tell use it as a mobile phone? No, right? What does it do? He will sell the physical device. That means that Verilog RTL code is becoming into, need to be converted into physical device. That whole flow is called as backend domain. Starting from that code till whatever you do, and by the time it becomes a electronic device, that whole thing is a backend domain. So in summary, software doesn't involve backend flow. Backend flow means what? Process of converting code into the chip. Chips doesn't have any concept of patch. See, the problem with chip is what? In software, let's say you have you have developed a banking application. There is a bug in the banking application. Instead of depositing, it is showing us withdrawal. Some bug. Okay, it can be reversed. Means whatever mistakes have happened, you can go back to 1 or 2 days where the mistakes have happened and you can reverse everything. And we can even update the software and we can install the new version of the software also. You agree, right? Let's say you went to a bank, there is an issue in the banking software, they can always go to the company which has developed the software and get a new version of the application. It is till that point it's possible. In chip, is it possible? Once the chip is manufactured, can we redo the chip and make it work? No, it is not possible. So the chips don't have a concept of patch. So how does chips have to work? One time that has to be the working. there is no scope for mistake. In software, there is a scope for mistake. Even if you do mistake, you can still recover, because there is always a patch. Even in Microsoft Windows, every day unwantedly also they keep asking me patch. Even if I don't want, they'll forcefully make me do. In hardware, can they give you a patch for your hardware, keep another another controller? They cannot do, right? So hence, the first time has to be the only time it works. If it doesn't work, the problem is what? Like you spent $5 million, or let's say whatever, $5 million in developing the chip. Next time again you have to spend that $5 million. You can do it, but the problem is the cost of redoing is too much. Many times what happens, if the chip doesn't go well, the company closes down, because companies don't have $1 billion, right? They'll have some $1 million, maybe 20-30 million. In that, if they can manage, fine. If they don't manage, company shuts down. That is what happens. I hope you have understood how software and VLSI differs, and why VLSI flow is more uh, important in terms of first time it has to work. There is no scope for any bugs. Let us now talk about pre-synthesis flow, front-end domain flow. These are the steps: requirements, architecture, RTL design, RTL integration, functional verification. Can I say that I will do this work first? First I will finish functional verification, then I will come to architecture? No, right? You have to follow the steps. Similarly, you go to backend domain flow. These are the steps: synthesis, GLS, DFT, physical design, STA, custom layout, physical verification, fabrication, and post silicon validation. And that order has to be followed. We discussed about lot of things, front end domain, back end domain. Let's try to understand what are the various job roles in these domains. Any those attending online, any questions you have?
No question.
Is anyone facing issue with the audio?
No, it's perfect, sir.
Okay, fine. So we have discussed about multiple things, right? Let's go back to software. In software, how many job roles you generally come across? Two job roles: developer, tester. Only two job roles, right? Because one person who develops the software application or software, and other person who tests the application or software, whether it's working or not. In VLSI, there are a lot of job roles. Okay, what are those job roles? Let's try to understand. Front end domain. If you go to front end domain, we'll divide the job roles into two categories: front end domain job roles and back end domain job roles. Whatever we discussed so far, you just add engineer in the end, that becomes job role. Design requirements, it is done by whom? Marketing team. Since they are not doing anything technical, can we call marketing engineer? No, right? We don't call marketing engineer. It's a marketing person. Architect, even he is not called as engineer, he is called as design architect. Who does RTL coding? They are called as what? RTL design engineer. The person who does RTL integration, RTL integration engineer. The person who does functional verification, called as functional verification engineer. Or what about the person who does DFT? DFT engineer. Now let's go to backend domain. In backend domain, the person who does synthesis is called as what? Synthesis engineer. The person who does formal, there will be one more step called as formal LEC. I mean, there, I told you, right, there are many things which sometimes you skip also. Like in house construction, I said, you don't consider interior design as one of the roles, but we do that, right? So like that, person who does is called as formal verification engineer. See, there are two verification engineers: functional verification engineer and formal verification engineer. DFT, again DFT engineer. Who does physical design is what called as what? Physical design. So in summary, everywhere just add the engineer in the end. That's now there is an important aspect. I mean, why we are talking about this? I will tell you. Who does STA? STA engineer. Custom layout? Layout engineer. Physical verification engineer. The person who does post-silicon validation? Post-silicon validation engineer. So these many roles are there in VLS. I have skipped another 4-5 roles actually, because I don't want to confuse you with too many things. I purposefully skipped few things. There will be something called IR drop analysis engineer. A lot of other things are there. No need to get into that minute extent. Okay. How many job roles do you see roughly? Leave aside marketing engineer, you cannot, marketing team you cannot become, right? After doing BTech, you don't want to get into marketing. Okay. How many other roles are there? Around 13, 14 job roles are there. So this is the problem with VLS. In software, things are simple. Why? Either you have to decide, I have to become a developer, tester, simple, no confusion. Then once you have decided, you know that if you want to become a developer, you have to learn C, C++, Java or .NET something. If you want to become a tester, you have to learn some testing softwares like Selenium, QTP, maybe some new things now, right? There are two aspects, right? In VLSI, that's not the problem. Problem is even bigger, because you have a lot of choices here. There was not much choices, so the decision making was much simpler. In VLSI, you have to choose. Let's say in front end, which one to go again. In back end, which one to go again. So let us just talk about this aspect. To understand, I mean, which one is better for you, let us understand the team distribution. If I talk about any company which is having a team of 50 people, let's say we talk about Qualcomm or any company for that reference. Okay, I just took Qualcomm as a reference. Okay, let's say we are talking about their mobile SoC design flow team. They will have a team which will make the chips, right? Finally, the mobile phone chips. Assume that they have 50 members. It's a hypothetical case. It could have been 100, it could have been 150 also. We are just talking about a scenario where they have 50 people. Out of 50 people, 25 to 30 will work into front end domain. So then how many will work into back end domain? 20 to 30, 25, right? Because 50 minus 30 is 20, 50 minus 25 is 25. So now out of this 25 to 30, there will be only one architect, because do you need to construct house? Do you go to 5 architects? All right, you go to only one architect. Design team will have around 4 to 6 people. It could be 4 people, 5 people, 6, anywhere. Then you have functional verification. How many people will be there? 15 to 20. This design includes design coding also, integration also. RTL design, RTL, you remember we discussed two roles, RTL design, RTL integration. Those put together, they will have only 4 to 6 people. Out of this 15 to 20, they keep some freshers. Now, let's talk about, where do you see a lot of people working in this domain? Functional verification, right? Because it is important. I mean, see, design, how it works is mostly it works on the reuse. Now you may say, why so, I mean, why few design engineers? Why more verification engineers, right? That's a natural question you will get. So the answer for that question is, design happens on the reuse. Let's say I want to develop something. Instead of me developing, I go to someone and I get the IP from them. I purchase the already existing thing and then I develop. Companies also do the same thing. Let's say Qualcomm is there. In the Qualcomm, I mean, the mobile phones you hear the term processor. Most of the mobile phones that we use, most of them, at least I would say 70% will have ARM processors. In fact, 90% I would say ARM processors will be there. They all come from one company called as ARM. ARM, you might have even heard, right? You would have heard Cortex processor, Cortex A57 processor, Cortex A72 processor. If you go one level down into the mobile specification, right, you will see that Cortex, this series of processor. They are all provided by ARM company. So there are two options for Qualcomm. One is they make their own processor from scratch. One is they go to ARM, they purchase that and they, for each chip they sell, they will give some amount to them. They'll give 50 cents, half a dollar to ARM. Just giving you example. Which one is better for them? They follow the second approach, because instead of they developing, if there is already existing IP from some third one, they get it. If it is already IP is present inside, they will use that instead of developing from scratch. So hence you don't need a lot of people for design purpose, because it works on the reuse. Simple example is, I want to construct a house. Someone is already making a bricks and selling me. One is I purchase the mud, I make the bricks, I then put it brick clean and then make the bricks. Which one is preferred? Second one. Cost wise, I would have saved by purchasing the mud and making bricks. I would have saved. But what is the problem? Then I cannot do. I need to employ a person who will do that work. So overall cost will increase for me still. So there they make a decision that no, we won't develop. As much as possible, we'll use the existing IPs. Because when I manufacture, I don't know how the brick will come. Can I give guarantee that brick will work properly as expected? No, right? The person who is developing for last 10 years, I know that his brick will surely work. So hence, what will I do? Will I start developing my own bricks, or will I purchase the bricks? Same thing here. They purchase the IPs so that they don't have to spend a lot of effort. And then what they will do, they'll pass on that cost to the customers. Instead of selling it the chip at $10, they'll sell it at $11. That's all done. But you still need to verify whether things are working fine or not. You still need to verify. That's where you need a lot of people. Now, how many people will be there into the backend domain? 25, 20 to 25 will be there. DFT will have around 2 to 5 people, 2, 3, 4, 5, like that. Physical design will have 10 to 15 people. STA will have 3 to 5 people. Layout will have 3 to 5 people. Now, totally roughly adds up to 50 people. Now, if you should not go to Qualcomm and do you have 50 people? They may have different number. I'm just taking what? A hypothetical case. But what is important here? There are more people into functional verification. Where are the other domain where there are more people? Physical design. That is where you see a lot of people requirements for these two domains. Now, generally what happens? I cannot keep all 15-20 people experienced, right? Is it possible to keep all 20 people experienced? Why I cannot keep? Because the cost will increase significantly, because hiring a experienced person, 3-year experienced person industry is 15 lakhs per annum. A good fresher can be hired at around 4 lakhs per annum. If the work is not very complex, if I can manage with a fresher with a good expertise, whom will I go with? Fresher, right? That's where, but they cannot have all the team with freshers. Is it possible to just run all the team with freshers? No. They try to mix this with some 10 experienced, 10 freshers, like that. But in other teams, they cannot do. Can I give architect work to a fresher? All right. Design work, as much as possible, they will manage with experienced people only. Here, they will only have one fresher maximum, more experienced people, like that. So, which domain has that scope to have more freshers in this flow? Functional verification. Which is the other domain? Physical design. Sometimes they keep 1 or 2 in DFT, 1 or 2 few in layout. So that is where you will see a lot of fresher hiring in this domain, this domain, this domain, and this domain. But lot of hiring happens in functional verification and physical design. But of course, there is a hiring in DFT also. There is hiring in layout also. You got it right? How it is working roughly? So that's where you see a lot of institutes offering training only in functional verification and physical design, right? Now, design verification, VLSI design, you got this idea, right? Now the question comes, how do I choose which domain to get into? Should I get into this one? Should I get into this one? We will talk about that shortly. I'll just give you a very brief answer. If you are interested in programming based job, I told you, right? Front-end domain is similar to software job role. You can go for front-end domain. Like C is their Verilog language. C++, similar to system Verilog. Java is similar to UVM. So if you are interested in programming kind of job, you should go for front-end domain. Okay. If you are very new to programming and never liked programming, then don't go for front-end domain. You will find it difficult actually. Because a lot of at one stage you need to have, see many times at times what happens is you don't have programming skill set, you don't have, I mean you cannot do much about it, because I come across few students who cannot do that. That's all. Whatever you do, I try to teach them at AND gate level, multiplexer level, very basic level. They cannot pick it up. At that time, you should not do. And of course, there is a flexibility where we provide. After 2 months of training, you can always switch to other domain. Let's say you join programming, I mean front end domain only. You don't like it after up to 2 months, you try and you are not able to pick it up. You can always switch to backend domain, or vice versa. You can switch from backend to front end. That flexibility will provide. Now, talking about design and verification training. Why we are talking about design verification training? Because I believe most of you are here for functional verification training or design and verification training. I told you, right? Everything is same. All these things are same. Whether you call design verification training, whether you call ASIC verification training, whether you call functional verification training, everything is same. Okay. One second. What is the time now? 10:54. Let's talk for another 10 minutes and we'll go for a break. What is the mode of training? Full week is available. It is meant for freshers. The full week training can be done online, can be done offline, can be done hybrid. Can someone tell me what do I think hybrid means here? Some sessions you can come to classroom, some sessions you can do online also. Let's say someone is in Hyderabad, they want to attend training, they can join online for a 2 weeks, few weeks or few months. They can come to Bangalore, they can attend, they can again go back to Hyderabad and attend from home. That is what we mean by hybrid mode of training, because 100% online may not be very effective, right? Because sometimes you want to see the person who is teaching you, you want to talk to him, you want to clarify your doubts, right? So that there you may require that personal interaction. So you can always come. That we do encourage. We don't tell that you are online, you cannot come to classroom. Your classroom you can't attend online. We won't tell, because why it works, how it works. Schedule is same. Like right now, you have few people who are sitting in the classroom. There are few people who are attending online also. For both of them, same schedule, same topic is taught. I'm not using the board also, I'm sitting here teaching, so you will not feel any difference at all. Now tomorrow, some of you can come to classroom, some of you can attend from online. You will not feel any difference as long as you don't miss the session. Other than full week, what other things will be there? Weekends only. It is meant for whom? Working professionals. It is again can be attended online, offline, hybrid mode of training. But for weekend only students, there is a flexibility. They will, because they are only attending weekend, we cannot do what we do for full week. Can we do the same thing in weekends? Difficult, right? It's very difficult. See, what I do for 6 days, full week is 6 days. I cannot do the same thing in 2 days. So what we do for them as a compensatory, we provide them access to all the recorded videos of entire course duration. Whatever videos we have, we provide, like my videos, mostly my videos will be provided to them. Over the weekends, we'll be having the live training sessions. During this whole training, there will be evaluation test to check your performance, and I'll be talking more about the course structure as we go forward. It's a 32 weeks course. I mean, it's been increasing only. Like last demo, I had planned only for 28 weeks. Around December when I did, it was only 28 weeks, but then I increased it to 32 weeks. Now the question comes, okay, in 32 weeks, training will be for 6 days per week and 4 hours per day, 9:30 to 1:30 every day. Recorded video access for 10 days for every session. Like even the regular students who attend, they will get the recorded video for 10 days every session. Training is divided into 3 phases. Phase 1 will go for 11 weeks. During the phase 1, we teach digital design, Verilog, And we also teach Linux basics and GVim, one text editor. These are the things which we cover in the phase 1. What is the duration for phase 1? 11 weeks. What about phase 2? It will go for 12 weeks. What do we teach in 12 weeks? System Verilog language and UVM. And other than that, soft skill training. I mean, how to attend the interviews, how to prepare, I mean, how to write email, basic kind of things. And Linux also we teach. By this time, by the time you are done with phase 2, how much total duration, how many weeks are done? 23 weeks are done. 23 weeks is roughly how many months? 5 months, roughly 5.5 months. I can say 5 months, right? From that point, placement support starts. You don't need to wait for 32 weeks to get placement support. You don't need to wait for 32 weeks. After 23 weeks, the placement support starts. After that, phase 3 will start. Now the question comes, let's say I got job. Then how can I do training? Simple, right? You completed 23 weeks and there are people who get job also. After 23 weeks, it is possible to get job. Very much possible, right? And I got into job. Then your question will be, how will I do the training once I join the job? Mostly you can switch from full week to weekends only training. In some cases, companies, even after you join the company, they allow you to do the training because they want you to be well skilled, right? See, if you ask a company you're joining, they're paying you salary. Do they want you to come with a proper skill set or only half skill set? Proper skill set. So they will give you, they don't have any problem because whatever new things you learn, whatever more you learn, it's good for them only, right? They will allow you to join. But in the worst case, you move to weekends and you get access to all the recorded videos for the remaining topics. What do we do in the phase 3? We move to the projects. See, here also we would have done projects. Simpler project like asynchronous FIFO, SPI controller, I2C controller, CRC generation. Some projects we would have done. That would be sufficient for you to clear the interview and gain the knowledge. The phase 3 is the most important thing where the actual learning happens. The project level learning happens. Projects like AXI based projects, AHP based project, Ethernet MAC, test bench development projects will be there. Okay. The entire verification of the Ethernet MAC. That will be the most important project where you learn everything. Python scripting will be covered. The phase 3, that will go for what? 9 weeks. Then SOC flow concepts will be covered. So in summary, this is meant for helping you get the job. See, phase 1 and phase 2 are helping you getting the job. Phase 3 is helping you perform in the job. Getting into job is one thing, performing in the job is another thing, right? So because in the interviews they will only focus on digital design, Verilog, system Verilog and UVM. They won't be able to check how you will perform in the job, right? Whether you will be able to understand a specification, whether you will be able to debug something properly. They can't check so much in the interview because interview goes for 1 hour, 2 hours maximum. In 2 hours, it's very difficult to judge a person skill set in depth. I can tell whether the person is good or not, I can tell, but I cannot really judge to a very core level. That is where phase 3 will help you. Where phase 3 will help you perform in the job. The important part of our training will be, I don't worry about the duration actually. If you ask me, do I want to finish the training in 32 weeks or 22 weeks? Tell me which one is economically beneficial to me. 22 weeks, right? Any day, 22 weeks is best because once that batch is done, I'm done with that batch. I don't have any responsibility. I can start a new batch and my trainers will be available for doing other batches also. Right now, what is my trainers are occupied for? Roughly 32 weeks, right? They may be doing other batches, but they are technically occupied for 32 weeks for that batch. If there is an option where I can wind up the batch in 22 weeks, I would be more happy. But then the problem is that quality of learning doesn't happen. Why that is important? Because most of the time, just getting a job is not important. Just getting a job is not important. You have to really, I have many I am engaged with some companies. Okay, I don't want to name the companies, uh, where they have hired 30 to 40 people, and all of them are again undergoing training with me. All of them are again undergoing system Verilog and UVM training with me. All 30 40 have undergone training already, and it's a big company. When I say 30 40, you know it's a big company, right? It's not going to be a small company. That big company, they have hired 30 40 people. Again, all that 30 40 people come to our institute and undergo training because they didn't learn the language properly. Now, I don't want to say anything against other institutes because I may have a lot of negatives. So my institute may have a lot of negatives. So not good for me to point out. What I'm trying to tell is, we try to make sure that we spend more time to give you that quality, because time is what translates into the quality of learning, right? Because if I try to do the same thing 20 weeks, you cannot do that, because everything requires some minimum amount of time to learn, and that much time we have to give. So yeah, I hope you got the basic overview, right? Now, preparing for a job. I think it's been a long time. We were discussing about the VLSI design and verification training. That is the front end domain, how the training is divided into 3 phases. And I told you that at end of every phase, there will be a evaluation test. Let's say once you are done with digital design training, there will be an evaluation test. Once you are done with Verilog, there will be an evaluation test. For every topic, there will be an evaluation test. Yeah. So we'll be having evaluation test at the end of every topic. Overall, you may have around 8 to 10 evaluation test. Okay. Again, evaluation test is not to tell someone is good or someone is poor. Idea is to figure out what level of support they require. Someone is good, comfortable, fine. Someone is not good, we analyze. Okay, we analyze what level of support they require. I mean, why the see someone is not able to pick up, what is that we can do to help? Do we need to arrange any one-to-one sessions for them with our trainer dedicatedly? Because many times people require that start. It's like a vehicle. Sometimes vehicle starts automatically, sometimes you have to push the vehicle to a point where it catches the speed, then it goes. So some people like that only will be there, where they don't understand the initial basics, but once they catch that initial thing, right, once they enjoy the things, they like the things, then things are easy for them. So we try to bring it to that level. If some vehicle don't even have a fuel and they don't want to start, then what do? We leave it. Some student doesn't want to come up, doesn't want to learn anything, doesn't want to join the sessions, then what do? Leave it. So that also happens here, because we have to deal with every kind of student, where student who is willing to learn but not able to catch up for some reason, we provide that support also. Someone who is good, he needs additional support where he becomes expert with the subject, we provide that level of support also. Someone who doesn't want to do anything, just want to come go, we'll also live with that guy. But we try to help. We ask him what support you need. We have a team who will call the person why you are not able to do well, what level of support you need, why you are not able to complete assignment. Now then it comes down to the student to get that support from us. Right? So in summary, that's how it is. The training is well structured. I mean, it is being refined, because I told you just some time back, I told till last year I used to call it as 28 weeks only, but actually it goes for 32 weeks. But then you don't need to bother, because your job support happens here itself. In many institutes, this is where they stop. The training itself stops here. But I believe whoever joins a company from the institute, our institute, their learning should be complete, right? Not just half prepared. If you send, it's problem for everyone, actually. Problem for the company, because by taking you with half preparation, they have to put extra effort, and which defeats the purpose of training. It's problem for you because then they will start telling you what kind of training you have undergone. Third, the problem for me because then they see that and then they don't hire my people again. The whole ecosystem gets disturbed. Disturbed means what? Companies will lose, student will lose, even I will lose eventually. Rather, what I do, let me spend more time and make you a good with what we are teaching. Okay. This will be the complaint you will hear. If at all you hear any complaint about our institute, this our program, right? You'll hear the courses are extended a lot. That you might be hearing, but I don't have an option. Thing is, Verilog I teach for 8 weeks. If I try to teach the same Verilog in 6 weeks, not possible. Because you give me a different set of people. Let's say I pick 10 people from IIT and IT. No offense, don't take me wrongly. I can teach the same subject probably in 6 weeks. Because the people from NIT, IIT may come with different level of motivation. Their motivation level is different. They pick up the things quickly. They go outside the hours and they work. I'm not telling anything against other colleges. And I get what I'm telling is here I get a mixed set of people, and I have to keep my training in sync with everybody's requirement, right? So there I cannot do the same 8 weeks in 6 weeks. That's the problem. Preparing for a job. What is the difficult part of the training here? Basically, is things move very quickly. Actually, in the institute, when you see things move very quickly, by the time you realize that digital design has started and something is happening, and it is already done, because digital design is done for 3 weeks. Okay, like whatever we are doing in this 6 7 months of training, it is equivalent to almost 1.5 2 years of your BTech. I can tell you that much. By the time whatever you learned in 1.5 year, you take any part of your 1.5 years in your BTech, first year and second year half one semester, what you learned, you learn similar amount of knowledge in 6.5 months. If I take an example of digital design, here we finished digital design in 3 weeks, fully focused on digital design. The same digital design you do for one semester, but in a more distributed manner, because every day 1 hour like that. But what we teach in digital design is at least 3 times more than what you do in BTech. What you see, you're getting the point. You're learning 3 times more in much shorter duration. That's what I mean by things move very quickly, and that requires you to be completely focused. Basically, the baseline is simple. You should start enjoying the training. It should not become an additional burden for you. Rather, you should agree, you should tell to your mind that I have no other option, I have to undergo training, I have to enjoy it. Right? You go to movie, let's say movie is not good and you still have to sit for 2 hours. What will you say? Even if the movie is not good, you start enjoying, then at least you will be able to sit for 2 hours. If you start complaining, what is this fight, what is this song, what is this dance, then for whole 2 hours you will keep complaining and you will not have any peace of mind. Rather, what you do, you should tell to yourself that anyway I have to undergo training, let me do it with a fun. That is what you have to develop here. Otherwise, every day you will find difficulty. If you don't enjoy training, you will find it very difficult to cope up with the training, because things move quickly. So that movement, quick movement, can be enjoyed only if you take it as a passion, okay, and start liking it. Like that, every topic you do, right, lot more is covered. Like Verilog I do for 8 weeks. It is a one full semester course. Again, the Verilog that we cover is at least 2 to 3 times more than what you do, and uh, much more depth topic. Why it has to be depth is, when you do in BTech, right, it is not done for a purpose of a job. It is done for the purpose of curriculum. See, they have a curriculum from VTU University or JNTU University or some Delhi University or whatever, right? That you have to cover this topic, and candidate has to score this. Here we have a target that the person has to go and perform in the job, right? If I just teach the language, he cannot perform, then everything gets disturbed, right? That's where I have to go in depth, and we do go actually. The topic starts always from the basics. When I start from digital, we start from what is truth table, what is logic gates, what is K-map, what is SOP, what is POS. At that level only it starts, and it goes quickly to the advanced topic. Same thing happens in Verilog. We start from what is multiplexer, how to write a multiplexer in Verilog, how to write the test file. take a half adder, how to write half adder Verilog code. That level it starts. But then you'll realize that by the time we reach 8 weeks, we would have done a lot more complex things. This overall things requires 600 hours of effort. Whatever we are talking, Verilog system, Verilog UVM projects, everything, if you add up, it will require around 600 hours of effort. Once you spend this, a very quality 600 hours, you are ready with the job and you can get a very good job. Okay. We have a performance tracking criteria, which we call it as gap. So we classify every student who joins into the courses, we classify them into 3 categories: a good performer, average performer, poor performer. Now, why do we do that? I don't really focus only on 20% of candidates. I don't focus only on top 40%. Not like we are targeting any ranks in IIT or ranks in some gate exam like that. Our idea is, how can I address 90% of the people? Because everyone has come for the same purpose. They want to join the institute and they want to get job. So if I start only focusing on 30%, 20%, our institute doesn't serve that purpose, right? It doesn't solve the problem. So what we do, we try to classify the people, and then we try to see what is the additional support this poor person, I mean the person who is not able to pick up, can be given. Like arrange some backup sessions, arrange one-to-one sessions, arrange a session where we help him do the things beyond the class timings. We do that actually, okay. But then I told you one thing: the student has to be proactive. I mean, if I will tell you, please be available today at 6 p.m., our trainer will take session. If student doesn't join, we attempt 2-3 times. Then what do? You stop it. You stop that person. I mean, we don't do anything beyond that. Okay. Performance tracking, we keep some criteria. How do I say someone is good? How do I say someone is average? How do I say someone is poor? Can I say if some student comes 100% attendance, can I say is good? No, right? So there is a criteria which we follow. Assignments completion is 50%. Whoever completes assignments on time properly, that's a 50% of performance. Okay. There will be a Google Drive where you have to submit all your assignments, and our team will be checking each and every assignments you are doing, whether you are copying from someone else, whether you are doing it yourself. That also they check, because given 2 things, they can easily check whether who is doing how, right? For every assignment completion, we conduct lab session. See, assignment is not something you just have to do yourself. Every assignment you get a support. Every assignment you do, it is done in the classroom. Like trainer will be there, like me, he'll be telling, now go to assignments to question number 3. You do it. He will give you 5-10 minutes. If you are not able to do, he will come and help you. If you're still not able to do, he will do and show you. That level of support you will get for each and everything. That's why training goes for almost 32 weeks. Right? If I have to, without that level of support, if I just have to teach and I just have to do projects and finish, that can be done in 25 weeks. Same thing can be done. But my point is, what that additional 7 weeks, if it can make you a better engineer, why not do that? Okay. The next will be 10% only for attendance. Attendance is not a very important criteria, but completing the things is more important. Then 20% for evaluation test. At the end of every topic, there will be evaluation test. How well you are doing. See, assignments, how can you do? You can do by just copying from someone else. There can be many ways assignments can be submitted, completed also. But evaluation test also gives a realistic criteria. Other than that, we make you do the presentation every month. Many times what happens, you have a knowledge, you understand the things, but you don't know how to explain the things. And that is what sells actually. Why my session sells? Because I'm able to explain what I know, right? If I know the knowledge but I don't know how to explain you, will you continue the training? Will you join the training? No. Right? That's why presentation, ability to talk, ability to tell what you're thinking is very important. So how do you learn? Does it come automatically? With my birth, did I learn the presentation skill? All right, I tried multiple times and eventually I came to a stage where I'm able to convince a group of 50 people that come join my training, I'll give you a good training. The same thing you have to learn, that comes with practice. So how do you start practice? Every month we make you do the things. First month you will feel difficult, second month you will feel little easy. By the time you reach fourth, fifth, sixth month, you're good, you're comfortable. That level we want you to reach. Then Student is given a topic and asked to do a presentation. Basically, whatever topics have been done, not like what is happening in Ukraine. That is what will give you some topics, what is being taught, then ask you to come up with a presentation on that one of the topic, 15-20 minutes presentation. That gives you that lot of confidence that I can explain the things. That level of confidence we want to develop in you, and that is what essentially becomes the soft skill training, right? Soft skill is not something like anything else. It's just how you present yourself, how you explain the things. Okay. 10% for mock interviews. Again, periodically we keep conducting mock interviews just to check how you are doing, whether you are able to answer the basic questions and all that. So this, you see, adds up to 100%. But what is most important, that we are giving criteria for assignments. And assignments are very important. Our assignments are very well structured. They give you in-depth exposure to the topic. And for every student who joins to the course, there is a dedicated WhatsApp group. Every student, doesn't matter whether they join for full course or 2 months course, 1 month course. We offer many other courses also. There will be a dedicated WhatsApp group. What is meant by dedicated? Only you are there, our trainer is there, admin is there, student is there. Whenever you need support, you post that request in the group. Generally, what is the advantage of WhatsApp? Tell me. Oh, what is the advantage of WhatsApp or email? Quick response. Mail, I haven't checked for last 2 hours. My mail, I didn't check for last 2-3 hours. I didn't check, but WhatsApp I checked during my break. Then whatever support I had, I did respond immediately. That support you will get immediately. Immediately means at least 2-3 hours you will get a response. Okay, so from student side, they need to be proactive to get that support. Okay. Final goal of, what is the final goal of this 32 weeks training is to make you an engineer, where enable you to work in the job independently. You go to, let's say you join some company, Intel, into a project. It's not like every minute you go to your lead, your manager, and ask, what is this, what to do, how should I open this, how should I read this. Does it solve the purpose of training? Do you think will it be a good way of for you to work? All right, how you should be able to work? He gives you the activity, you understand what is activity, you understand what need to be done, you do it, and you tell him activity is done. That is what I mean by this thing, enable you to work in the job independently. You don't need to do very complex things, you don't need to invent a chip, you don't need to invent any new technology. Whatever is there, understand that problem, just come up with a solution to that problem, implement that solution. That's what training will do. Training will not make you any big R&D engineer, will not make you any technical big or anything, right? It will give you basic common sense with respect to what you do at the job. Okay. And it's a collective effort. Institute plus student, this is very important, because we do put a good amount of effort. I mean, as a training institute, we do understand responsibility of a institute, and even I understand my responsibility. Many times students don't come up to that level, they just don't put effort. What can I do in that case? And it really happens. Eventually, for initial 3-4 weeks, they have the motivation, they come, and after that they stop. That level of that motivation need to be maintained throughout the course, and they need to put effort. That's why I said it's a collective effort. Even getting job, everything is a collective effort. Just because you join, just because you pay fee, you don't get job. You get job because you learn the subject. We will enable you learn the subject. Now, I think we have discussed it. We do get good testimonials. I mean, and this, I thought, why don't I just share the snipping of few of the testimonials that I just got in last 2-3 weeks. So this is one of the student who joined. I don't want to name the person, and I don't want to share their numbers. See, he just mentioned, like, yesterday he sent, actually. uh, you can read this once, it might just help you. Thank you. I realize the content, syllabus, and the teaching of VLSIGuru, which is far better than all other institutes, as well as the teaching and use case are very practical and at the industry standard. I'm becoming big fan. Uh, Point I'm trying to tell is, I didn't ask him to send. Okay, don't think that I asked him to send. See, the context is different. I mean, our earlier conversation happened in a different context, and I was telling this is the individual WhatsApp group that we created. Okay, in that he joined. company where there are students from other institute also. He was able to compare his training, his level of learning with other learnings, and he was able to make a significant difference in how he learned the subject. It's a language, how we thought the language was different compared to other institute. And I don't want to say any negative about other institute because they have their own strengths. Okay, this guy is again in 12th January he messaged us. He is, I want to thank you for the course and support. Finally I got placed in Qualcomm Canada. And he was only e-learning student. EL stands for what? E-learning means he only went for recorded videos. He didn't even attend most of the live sessions. He was only going through the recorded videos, and through that he was and which domain he got trained in? PD, physical design. By attending physical design in a recorded video manner and through some live support, he was able to get into Qualcomm Canada. And we do keep getting messages. I thought, why don't we show this to the students so that they understand that we do provide a quality effort. Not that every student don't get into Qualcomm Canada. Not every student get Qualcomm offers. Not every student learns to this extent. This guy was really different. The person who gave this review was really different because he put a lot of effort. Even he joined in e-learning only actually. Initially he joined around, you can see June 22. Actually in the background, this is JUN22 is there. When he joined in June 2022, he joined around December, January, he joined the job. By January he joined. Initially he was thinking, I mean, when he joined digital, right, he was finding our pace of teaching was slower compared to his level of learning. He wanted to do it quickly, so he moved to e-learning where he was able to do at his own pace. Then we used to arrange some weekend sessions for him, and eventually he got job in January. So that level of motivation is required. Just thinking that I will pay the fee and institute will get me the job doesn't happen. It happens, you complete the assignments, you will 100% get job. People ask me, do you give me 100% placement assurance? I will tell, give me 100% assignment completion, then I will get you job today itself. What is that assignment completion under? Doing these things. Properly will give you is it will give you confidence about yourself. See, right now you know that you are theoretically good. Some BTech subjects, you know, you're fine with that. But to the job, are you prepared or not? You don't know. This will give you that confidence that I'm good, I can go to any job and I can perform. That level of confidence it will surely give you. So the training will focus digital, Verilog, system Verilog, and UVM. It will make you a very learned professional over 8 months, 7 to 8 months time. It will make you a learned professional. Yeah, this is a brief about how the training is structured. Now coming to the skill set that you require. First is you should be learning. I think it's not in the proper order. You should be good with digital design. Should be very good with digital design. Linux basics, you know, you should know how to work in Linux operating system. It's a common skill set, okay. Other than that, you should be good with text editors, like how to use GVim text editor, okay. Like GVim, Notepad++, Nedit. There will be few things. Other than that, some basics of CMOS and FinFET. Very basics, okay. What is meant by PMOS? What is meant by NMOS? How a CMOS inverter works? That level of basic thing you should know. And other than that, some scripting languages like either Perl, Python, or TCL that should be known. If you ask me, do I need to come prepared with everything? No. We will teach everything from scratch. Other than that, as a front-end domain, you should be good with standard protocols, on-chip protocols, peripheral protocols. Then you should have good programming expertise. Means if you want to get into front-end domain, you should have good programming expertise, like hard Verilog languages like Verilog and system Verilog should be learned. Debugging expertise should be there, like debugging the simulation failures, tracing the issues in the tools. This level of expertise you require if you want to get into front-end domain. Same thing if you want to get into, let's say, other than that, debugging the failing test cases. If you want to get into backend domain, what skill set you require? You should be good with VLSI technology concepts, like what is meant by uh, circuit delays, how the LC circuit works, how the CMOS works. In depth of semiconductors, you should be good with. because backend domain doesn't have much to do with the program, like concepts like resistor, inductor, capacitance, parasitic capacitance, different types of delays, how the clock generation works, various very fundamental things. Tool expertise should be there. In backend, everything is done using tools, like what we call as EDA tools, like EDA tools, ICC2, prime time, design compiler, star RC, those kind of tools you should be expert with. Scripting expertise should be there. TCL you should be very good with. IC fabrication concepts, device and semiconductor fundamentals, like starting from the fundamentals of conductors, insulators, semiconductor, till you learn everything about that. So this is the kind of expertise you require if you want to get into backend domain. Do you see any programming term here? All right. So that means if you are not looking for programming based job, go for backend domain. But let me tell you one thing. Front-end domain is more relatively peaceful job. Peaceful means what? 9 to 6 kind of job. Front-end domain. Back-end domain at times involves a lot of uh, working beyond the office hours. Sometimes people have to work late nights and all that. Front-end domain generally don't have. If you regularly go to the job, work properly, you can finish the work in 9 to 6 kind of. Why is it so? Is you see, the domain, the flow itself is such that uh, I'll just take. In this flow, which one do you think is coming first? Front-end domain happens first or back-end domain happens first? Front-end domain, right? So here what happens is that this will be distributed. Let's say the project runs for 8 months. Your work is distributed over 8 months. Back-end domain work only happens for 3 months. Your entire work gets distributed only for 3 months. Tell me where the work distribution happening more evenly? Front-end domain, right? So it is more relaxed going by that. In back-end domain, all the work you have to do, all your work you have to do in the last 3 4 months. So hence your work automatically gets increased. Other than that, I want to tell you one more thing before I end this my part of the lecture, is that uh, you should also explore FPGA domain. Should also explore. Just think about FPGA domain once, because even though there are 85% companies who work into ASIC, how many percent are there in FPGA? 15. But if you search how many training institutes are there in FPGA, just go to Google. And Intel provide you training. All right, Intel is just marketing their product. So Intel is not a training institute. So this is the first thing that is coming. Udemy, they will not be in depth. They'll just give you a top level overview of what is FPGA. Coursera, Course Central. Then the very first page that comes is our page. And Microchip also won't give you training. Then this is also my page only, FPGA Guru, my page only as a dedicated FPGA training. Then Xilinx is different. Daulos is, you can't afford Daulos training. $3 4 thousand will be there. Right. So the point I'm trying to tell is try to think little differently. I'm not telling go to hotel and become a do some other course. In VLSI, in ASIC, sorry, in VLSI only there are multiple sub aspects are there. Think in that direction. Yesterday I was talking to my trainer. Because I wanted to tell to the people that FPGA domain is also good. Then I asked him what all companies are there in FPGA company. He started giving me the list actually. I asked him, he's my trainer, Hariprasad is our FPGA trainer. I started asking what are the FPGA companies are there? Mistral Solutions, Centum, Redf, AMI, Capgemini, Xilinx, VBDN. Then he said these are all companies. These are some companies. Then he further gave me another list of companies also. Okay. Do you think around he gave me a list of 30-40 companies actually? Probably you might have seen list was close to 35-40. Don't they require freshers, or will they only go for experience? They will go for freshers also, right? So please think in that direction. Right now, the why the problem is many people join into physical design or institute. At one point, it becomes very difficult to provide job opportunities to all of them. Why they come to physical design is they don't want to do programming. And the domain where they don't require programming is the backend domains, physical design, DFT, custom layout. And physical design happens to be a domain where they think a lot of opportunities are there. They join, and there it gets too much crowded. Crowded means what? If I have, let's say, 60 people, there are only 10 opportunities or 20 opportunities. Can I give 20 jobs to all 60 people? Not possible, right? So only out of that 60, top 20, 30 only will get placed. I'm just giving you some numbers. In other domains where FPGA kind of domains, there are no institutes at all. Have you seen Sandeepan is there? I don't know why Sandeepan is not coming. Some other institute might be there, maybe one or two institutes. You should think from that perspective. Okay. Because many times I tell to the people, think about other domain. FPGA, it requires only 30% of programming. You just need to learn only Verilog only. You don't need to learn system Verilog UVM. Verilog you should be very good with. Then remaining you have to learn the FPGA flow, how to work with the FPGA board and all that. People hire actually. This company is what my trainer gave is not like just for showing purpose. He works in FPGA and he sees a lot of opportunities also. So I want you to think from that perspective also. Okay? Don't get into too much crowded domains where it becomes a competition at one stage. A domain where there are, see, many times companies come to me and I don't have a people, I send them. I tell them I don't have people. Okay. So think in that direction. Any other questions? So this is a brief about. Now you may ask which one is, does FPGA has ASIC has more career opportunities or FPGA? Both has opportunities. See, the thing is naturally adjusted. If there are 85% companies, more people will be there in ASIC. 15% opportunity means less people will be there, and relatively lesser competition will be there. Salary wise, both companies will pay you good, right? That's the brief. Okay. For me, it doesn't matter because at the end the fee is same, course content is same, everything is same. Probably business wise sense, ASIC is better because I do ASIC. Some other trainer does FPGA, so my margin will be less. Where do I have better margin? ASIC will have more margin, right? Because I teach ASIC, other trainer teach FPGA. But then I have to look from perspective, what is the chance of me giving a placement opportunity to a student? If I prepare a batch of 20, I go to a company, all the companies he listed, and tell to them that these 20 people are well trained, hire them, at least all of them will consider, please send me the profiles. So that's about it. Any questions you have? Yeah.
Uh,
I
Hello.
didn't
Yes,
want
sir.
to put too much technical into the functional verification training. I mean, our training will be like most of you are here for functional verification training. What is functional verification is the process of verifying whether your Verilog code that you developed, RTL, I said right, Verilog RTL coding, is it working fine or not is called as functional verification. For that, we develop something called as test bench. BFM, generator, monitor, coverage, scoreboard, coverage, reference model, everything. That will tell you that using that we prove that the design is working fine, that code is working fine. To do that, we use languages like System, Verilog, and UVM, and we will be doing everything in depth. Uh, I would probably say our course is the most elaborate course. Even we are well partnered with almost 15 companies. What the companies do is they hire the people, they give it to me. I don't want to show the companies because for companies it becomes very confidential, right? Let's say one company gave me 70 people. They don't want that information to be in public domain. Now this is being recorded. This video is being recorded. It goes into public domain. So I won't show those details. But we are connected with almost close to 15 companies. What they do is they hire the people, they give the batch to me, I train them for 6 months, and I give back the people to the companies. So there are many companies where we are partnered in that model. Okay. In summary, the companies do trust our training flow. I have done training to Intel, Qualcomm. I mean Qualcomm in a e-learning mode. So we are engaged with the big companies and even smaller companies also. So that's a brief about the training. Now if you have any questions, I can answer those.
Sir, excuse me, I have one question.
Yeah.
Can you hear me, sir?
Front end will be same, but in case of FPGA, you need to, I'll tell you, you need to learn the other flaws. Once you know how to develop the Verilog code, you need to learn how to synthesize the Verilog code, how to put it onto the FPGA board, and when you put it onto the FPGA board, you need to do some timing closure so that the chip should work properly, right? That FPGA board should work properly. There you need some additional flow where you will be doing hands-on on the board. You need to learn both the skill set. In ASIC, what happens is you are either a front-end engineer or you are either a back-end engineer. In FPGA, you need to learn entire flow, and it's not going to be very complex actually. Yeah. Will we get offline FPGA training? See, the trainer is currently based out of Bangalore, so it won't be offline training. See, it will be mix of offline and online. The main trainer is outside Bangalore, so he will do online only. The supporting trainer is in Bangalore, he will do the offline training. Right? It can be mix of, it's a hybrid model, I would say. Okay. DFT session. So the DFT session will be at 4 p.m. The DFT demo session at 4 p.m. What exactly is DFT? Let me give you a brief. DFT is about finding the manufacturing defects. See, once you manufacture the chip is very small and it's manufactured at 5 nanometer, 3 nanometer technology. Nanometer, you know, right? Very, very small. At that level, there could be manufacturing defects. Functionally, everything is good. Due to what is manufacturing means, you are putting two metals with a gap of how much? 5 nanometer. They can just get shorted, right? Then what will happen? Chip will not function. So somewhere in the chip, that kind of fault is there. Somewhere in the chip, and I don't know where exactly. To catch that kind of defects, we use DFT. DFT involves some techniques called as scan, ATPG, compression, simulations, built-in self-test, JTAG, boundary scan. There are multiple things. So that is what DFT engineering does, to come up with how to test the strategies, how to check these kind of faults. Okay, it's not just for this. There will be various types of faults. Okay. Next. E-learning course means, yes, it is the recorded videos. But in e-learning course, it's not just the recorded videos. There will be dedicated weekend support sessions every week. If I just give videos and ask you to prepare, it's difficult, right? I mean, you can't really learn everything only with the videos. You need someone to guide you, someone to support you with the project, someone to monitor your performance. So that's where there will be dedicated weekend sessions every week, and it is mostly meant for working professionals. And the problem is, only if I do only sessions on weekends without any videos, that is also a problem, because only on weekends I cannot do everything. Full week is fine because there is a lot of time to do. So this is where we go for a hybrid model where you attend the sessions on the weekends, you go through the videos during the weekdays. For someone who trained in ASIC, what else knowledge he requires to work in an FPGA? See, FPGA, they need to understand FPGA board. What does FPGA board makes up? Then they need to learn how to synthesize, how to convert the code into a netlist, and how to put that netlist onto the FPGA board. Then while doing that, they need to learn the flow. I mean, Someone who is trained in ASIC, they need to do one entire flow on FPGA to become comfortable with the FPGA flow. Does the class start from 25th Wednesday? Yes, it starts from 25th of this month. Yes, it starts from 25th of January. The next 3 days, 22nd up to 24th, is for enrollment purpose, because some of you may not have enrolled. So it is like time for you to enroll. Reason is, if you miss one session, right? Let's say if I start session on Monday, some of you enrolls by Tuesday, you miss 1 or 2 sessions. You find it difficult to cope up with the remaining session, because once you miss 4 or 5 hours of training or 8 hours of training, you lose the track. Is DFT domain DFT into front-end domain or back-end domain? Tell me. Tell me. Is front-end domain or back-end domain? Both, right? Because DFT happens in front-end domain also, DFT happens at back-end domain also. Technically, if I have to place by the way we are dividing subject, it will come under back-end domain. Why? Because there is no programming involved in DFT. You in DFT, as a DFT engineer, you don't do any programming, so hence it becomes back-end domain. Could you share the detailed course curriculum? You need to go to the training page. Please go to the training page, VLSIGuru.com. There, freshers course. These are all the fresher courses. Okay. So here, if you go, you can see the syllabus. You will see the detailed syllabus. What is covered? Actually, it's not even 6.5 months. Now I would call it as 7.5 months. But the point is, you don't need to worry about that 7.5 months duration, because you are ready for the job by 5 months. Remaining 2.5 months is that additional support to make sure that you do well in the job, right? So here you will get the detailed syllabus for each and every topic. Like that, similarly, you can check for every course, FPGA, physical design. Every course you can go and check. Even for design for testability, you can check. What do we do in the initial 6 weeks? In the advanced 16 weeks. DFT won't be such a long course. DFT will be finished in 24 weeks maximum. Okay. 6 months, that is. Okay. That will cover everything. Again, our DFT course is the most exhaustive course. I'm not telling for the sake of telling. There are only 2-3 institutes. If I just go and search DFT training, there are hardly 3-4 institutes. I know what is covered in each institute. I know the content, what is covered in each institute. We have the exhaustive content. I mean, what I mean by exhaustive is the topics like that we cover. Uh, the topic like MBIST, JTAG, boundary scan. No other institute covers this topic. They cover only to the extent of scan, ATPG, compression, and simulations. We do cover more in depth of PFT. Next, any other questions? Uh, is there any limit, watch time limit for recorded videos for weekend students? List down all the questions. Detailed course curriculum I have shared. Is there any watch limit for recorded videos for weekend students? Technically, no. Generally, we keep the limit. Technically, we for every course we give this many hours. Let's say the course is for 100 hours. We keep the watch limit at 170, 180 hours. The video content is 170, 100 hours. We keep the content at 170 to 180 hours. But it can be increased. The whole idea is people misutilize sometimes. If I give to one person, 2-3 people use that. To avoid that, we have kept that limit. But if you are using genuinely yourself, we will do that support. But when we figure out that it's not used properly, you're logging in from multiple IPs and you're doing something which is not right, we stop it. But as long as your intention is correct and you want to use the videos only for self-learning, you are watching multiple times, we have no problem. Because we have to protect our business, right? What is the minimum qualification required to enter VLSI domain? Can non-technical background guy also enter? No, it should be BTech. At minimum, BTech or BE in ECE, Triple E, electronic instrumentation. Anywhere electrical is there in your degree, anywhere electronics is there, even CSC people, computer science people also can enter. These are the possible domain people who can enter. Someone is, let's say, from mechanical, they cannot get in. I mean, there are exceptions. I have some 3-4 people from our institute who got into the job from mechanical also, but in general, companies don't accept because it's a completely different skill set. Right? Mechanical is a different skill set. So, except for that, these are the domains which are possible. What about weekend classes? They will start from coming Saturday. The people who want to enroll for weekend classes, they can start from today itself. I mean, anytime, because you don't need to wait for weekend classes. See, those who enroll for weekend courses need to be a lot more self-motivated. See, in full week, what happens? There is a trainer who tracks you every day, and if you are going in the wrong track, you are not learning, he will correct you. But in weekend, what happens? Interaction happens only on the weekends. Remaining time, you need to have motivation to complete the course. So you don't really need to. What is the point I'm trying to tell? You don't need to wait for the class to start on Saturday and then start the learning. You can enroll today. You can get the videos. You start the learning. By next Saturday, you complete as much as possible and utilize the next Saturday session for discussing the topics with the trainer. That level of motivation is required. From our side, what we do is we give you the schedule. See, we have our own e-learning portal in skill.in. Like you see Udemy, there are portals, right? We have our own portal where once you log in, you get the entire material there. Let's say if you start off with digital design, for example, here you get once you enroll for e-learning course, you'll get the videos, you get the schedule. See, schedule is implemented in such a way that we divide the learning into 3 possible categories. Either you want to learn in a relaxed mode, either you want to learn in a normal learning mode, you want to learn in a quick paced learning mode. See, based on, like, let's say you have 12 hours per week, you go for relaxed learning mode. You have 18 hours per week, you go for normal learning mode. If you have 24 hours in a week where you have that much time you can spend for learning, you go with quick paced learning. Accordingly, we give the schedule, how many units you need to complete in each week, depending upon what is your mode of learning. And accordingly only trainer will support you. Trainer will know that you are learning in this mode. Trainer will tell you go through these videos and he will cover those specific set of topics for you in the upcoming weekend. And when you go to assignments, presentation, you will find all the presentations here. Assignments, there will be detailed assignments for each and every topic. Like, assignments are quite in depth. They will cover all the topics from scratch. I mean, they won't be like just one line. There will be more detail. For each and every topic, it will be detailed, and you get support for each and every question. Let's say you are stuck somewhere, you post that question in the WhatsApp group. Trainer will respond to you if required. I mean, this is for e-learning students. Those who are attending live training, of course, they do get this access. See, as a live training student, also you have access to this thing. But your support you get in the class only. Like you are attending the class, you are stuck with some doubt. You ask me, I clarify. And other than that, notes and labs also will be there. So like that, everything will be in a well-structured manner. You don't have to go to many places. Everything is available in one place. The similar thing will be there in every course. Let's say you go to Verilog. Videos schedule will be there. Again, we would have given a schedule specific to Verilog. Presentations will be there. Assignments will be there. A detailed set of assignments for Verilog, which again start from the basics, right? how to write a half adder. I mean, how to implement that Verilog code and test bench for half adder, which will be not just like one statement. I won't give one statement, write a Verilog code for half adder and write the test bench. I'm giving you a detailed steps. What is a student requires here? You should have that basic interest to at least read this and try to understand what to do and implement this. And let's say you are stuck, the trainer will be there to support you. If you don't do any of them, institute cannot do anything. Similarly, notes will be available. Like that, it will be a well-structured course. Similarly, if I go to system Verilog, I think I closed it, but you will find that support throughout the course. Okay. If someone is asking, is physical design a pressurized job? If you enjoy the physical design activity, I mean the work, you won't feel the pressure. I told, right, you go to a movie. I was giving an example. You don't like the movie, you are not enjoying anything, then you will feel that 2 hours will feel like 10 hours for you. If you start liking it, that 2 hours will feel like 10 minutes. You will feel why the movie got over so quickly. Same thing with physical design. If you don't like it and you start doing the work, every minute you will feel the difficulty. If you like and you start learn from the fundamentals, why physical design is done, how it happens, from you won't find the pressure. Even if you have to work for long hours, you won't feel. But in general, if you ask about the number of hours, yes, many times physical design requires you to spend more hours compared to a front-end engineer, because the nature of job is like that. Because the chips are very complex. Any small mistake you do, to redo all the thing, you have to spend 6 to 8 hours again, because you are working at how many gates level, hundreds of crores of gates levels. Small mistake you did, to correct that, you correct it, then you have to prove that it is working fine, right? It takes a lot of time. That's why it is time consuming job. Next, uh, let's go to this question. IT employees having 7 years experience, is it recommended to enter into VLSI? First, will he be considered as a fresher? See, in any case, 7 years experience means you will never be treated as a fresher. What is fresher definition? Recently passed out, right? Last 2 3 years passed out, either this year or last 2 3 years at best. That means for someone who is in 2023, someone who is looking for a job in 2023, 2020, 21, 22, 23 at max. They won't even probably consider 2019 also. That means you have to try as an experienced person only. Now, let's say as an IT person, you are working in either Wipro, you're working in TCS, you're working in HCL, you're working in Tech Mahindra. Any of these companies, you can easily switch into VLS. Easily switch. Even if you worked in a different domain, let's say you worked into some automation, you worked into some software, which is nowhere related to VLSI, you can still switch into VLSI. Let's say, but you are from a different company, Wells Fargo. Do they work anywhere? Why is it easy in these companies? Because Wipro has a big VLSI division. TCS has a big VLSI division. I mean, not big, a small one. Okay, but Wipro has big one. HCL has a big division. Tech Mahindra has a big division. Even Capgemini, let's say. You see, these days all major service-based VLSI companies have their own VLSI divisions. Actually, service-based software companies have big VLSI divisions also. If you are into any of these companies, you can enter into VLSI as an experienced person only. What you have to do, you have to join the training, do the projects, gain expertise, show around 2 to 3 years of experience, then enter. You learn the subject, you do, once you join the job, you do well in the job, you become expert, then you can utilize all your 7 years of experience. Because right now you can't immediately join us 7 years in VLSI, right? Because you can't do that 7 years of work with 7 months of training. 7 months of training cannot make you on par with 7 years, but it will make you on par with 2 to 3 years. You join the job, you gain the skill set, then you try as a 7 years in VLSI only afterwards. Is it recommended to enter into VLSI? It's your call. Let's say for example, you're currently you're getting 7 years, you're getting around 9 lakhs salary per annum. Then yes, you should definitely switch, because same 7 years in VLSI, you may get even 30 lakhs per annum. It is possible, very much possible. A 7 years person, experienced person in VLSI can get easily 30 lakhs also. Okay. See, if salary is the motivation and the work nature of work is motivation, yes, you should do. Okay. But if you are already meet some of these criteria, then there is no reason to change. Let's say you already get a very good salary, and then there should not be a reason. Okay. I enrolled for front-end course, but I want to switch to back-end course. Can I do it now? Yes, you can do it. I told you, right? Any student who enrolls for any course has a flexibility to switch the domain up to 2 months, because most of you are freshers. See, my level of understanding of subject is different. Your level of understanding of subject is different, because probably 15 years back I was like you. So you may make decisions which are not, which you wouldn't have thought so many things while making decision. So up to 2 months, we give you that flexibility where you can change your decision and switch to some other domain. The course is completely student centric. Let's say you are in BTech, or you're completed BTech, you have some in between some work for 1 month, you want to take off and you want to restart after 1 month. We give you that whole flexibility. Means up to 1 year you just join anytime. I mean, the point is not just about switching the course. We try to keep the course as much flexible to the student as possible. Okay, rather than asking students to align with my schedule or my way of running the institute, we try to align with how can we make the institute more student friendly. Next, if we reject job offer letter due to company terms, do institute provide other job opportunity interview? See, due to company terms and conditions, you shouldn't even apply for that company. Getting my point, right? Let's say the terms and conditions, they won't tell after you join the company. Even before you apply for the company, you know the terms and conditions, right? You know whether you are going to sign a bond, you know what is the salary they are going to provide, everything you know. In that case, you should not apply. If you applied and you got a job, institute doesn't provide next level of support, because we have to, not only for one student, we have to provide support for every student in the institute. Okay. So what is my answer? You read the terms and conditions, don't apply. You should not apply just to check whether my preparation is good or not. You should not do. If that is what you want to check, you come to our team and you ask, I need a mock interview. We'll conduct a mock interview for you just to check your preparation standard. Can we do both front end and back end course parallelly? Is it possible? Not possible, because it takes, just to gain expertise, become a good with front end domain, it takes full 8 months. I'll tell you, full 8 months it takes to become expert with only front end. But again, to get a job as a fresher, you don't need to be expert. 5 months is very good actually. That last 2.5, 3 months is what makes you expert with that subject. Okay, doing it's not suggestible, not good. Will you provide placement support for weekend course also? Of course, yes, because everyone, online students also provide, everyone gets the same support. Everyone is added into the same WhatsApp group. Generally, what happens? For all these things, we maintain one common WhatsApp group. For DV, design verification, one group. For FPGA, one group. For DFT, one group. For PD, one group. So like that, there will be 5, 6 different groups will be there. So whatever requirements we get, we keep posting in that groups. And the students apply into that. We'll give a form where they have to apply, and those profiles we share with the company, and uh, the company will take it forward. How placement work is, it is the previous student who make the impression. Like say one student went, I was showing you one review, right? He joined BitSilica. If there are 10 students, tell me after 3 months if BitSilica wants to hire. whom would you think they will prefer from our institute? Because not only him, they have made similar observation with other students also. There was a few more students who have joined in last 2 3 months who have joined, and they have done well. I think they were able to differentiate themselves with the other institute students. I can probably uh, show. I think he joined. He was a March 2022 student, and he joined. And somewhere he might have given that kind of feedback also. I don't know exactly, but anyway, not to go too much deep into it. The point is, he the people who joined from our institute into the companies, they were able to show the differentiation with the other institutes. Now when the people show that differentiation, the impact doesn't show up in the same day, same month, over few years it shows up, because next time when they want to hire, they give little additional preference to our institute, because they know that the quality of people will be relatively better. But again, as I said, it's a mutual effort where student have to put effort and learn. Not everyone is Niranjan, not everyone is uh, Irshat. Yeah. Other person was Irshat. There are a few more people who have got through. It's their effort and the institute guidance is what made them reach that point. Next. Yeah. I think we're probably done with all the questions. Can institute provide? Yes. Next question is what? Can institute provide internship certification for 4 to semester students? Yes, we do provide. We do provide. Yes, it can be submitted in the college for attendance. We are not just a institute, we are a company, registered company, where we do things outside of the training also. So you can show your internship as part of that company and you can submit that. And even the people who have joined for, who are in MTech first year, let's say some of your MTech first year, uh, let me tell you, I have many cases where people have done Verilog training with us, MTech first year. Like you go to VTU, Manipal University, they get this Intel and Qualcomm kind of companies visit for internship, right? Whoever has done our Verilog course, they had almost 100% success ratio. They were able to just get through. There was few students from LPU, Lovely Professional University, right, in Punjab. Out of 60 people, he was one student who came to our institute. He came during lockdown actually, and he did the training, and he is the only person who got into Infineon among 60 people. Like he went back, and after the third year he came in BTech actually, BTech third year. I think fifth or sixth semester he did the Verilog training with us, and after that he is the only person who was able to get through Infineon interview process for internship. Okay. All I'm trying to tell is the course is fits into industry requirement, what companies look for and what we teach both align. How much pay scale can we expect as a fresher? See, as a fresher, you can get anywhere from 2 lakhs to 20 lakhs. See, companies are two types: product. See, the product company salary ranges from 2 lakhs to 6 lakhs. Service company ranges from 6 lakhs to 20 lakhs. I have one of the company who has paid 20 lakhs also. Few product companies who paid 15 lakhs also. Few product companies who paid in the range of 6 7 lakhs also. Then I have some service companies who paid in the range of 2 lakhs to 6 lakhs also. Why is it now? The question comes: I'm a BTech engineer, I'm an engineer, why should I get 2 lakhs? The reason is everyone pays because only when you generate a revenue for them. Point is, nobody gives. You go to your neighbor and ask, give me 100 rupees. He won't, he probably may not give you. May give you out of 100 rupees, out of just your connect with him. But little more you ask, he won't give you. Because everyone gives you money when they get some productivity out of you. When you just join the company, services company, oh sorry, I think I reversed. When you join the service company, they make a revenue when they start billing you. You have to go to Qualcomm, Intel kind of companies, and you should start generating revenue. During that time, they are paying out of your pocket, their pocket. You don't generate any revenue for them. They start paying you still. So that's where the salaries will be less. See, don't think that every company pays 2 lakhs. No, companies do pay 3 lakhs, companies do pay 4 lakhs, companies do pay 5 lakhs. Just giving the lower range and the upper range also. Okay, because I don't want to just put 4 lakhs and give you a false impression. But eventually what happens, even though you join at 2 lakhs now, there's a very good chance that within 3-4 months the salary can become 5 lakhs and 6 lakhs also. It won't be like 10% rise. All they wait for is, company waits for you to become billable. When you bill, you generate a 20 lakhs revenue. When you start billing, you generate a revenue of how much? 20 lakhs plus. Then they will give you easily 6 lakhs also. But till then, you don't generate any revenue. In product company, it's not like that. From the day one, you are into the project, so they can give you the salary. But the level of expertise you need to get into product company is little higher, because you should be good with the subject, and they expect, they have different criteria, of course. Yeah. But even from here, you can easily get into product company. I do have people who have got into onsemi, they have got into Micron, Microchip, and Samsung. People have gotten. So it's not any exception, but mostly services companies where more hiring happens in the institute. Regarding the number, salary won't grow like 2 lakh next year, 2.2 next year, 2.4. No, it suddenly jumps to 6 lakhs, suddenly jumps to 11 lakhs. This happens in the industry. This is how VLSI salaries grow. Next, you may ask, will it become 1 crore? No. There is a limit, of course, for every experience level. At that level, they stop. But then it goes to a very comfortable level. Any questions? I have answered, right? Will you provide placement support for weekend course? Yes, we do provide. Okay. Any other questions? I told, right, for every student who enrolls, support is same. Online, offline, hybrid model, e-learning, everyone gets a support, because there's no reason for me not to provide support, right? I will of course provide. Only thing I check is whether the person quality of learning at least meets the minimum criteria. You don't need to be expert, but at least some basic things should be there. If I covered 100 things, are you able to answer at least 30-40% of the things? If I have that content, then only I provide support. Otherwise, I ask you to continue to prepare and then come back. Otherwise, what happens is, you, without any preparation, you go to a job, you don't do well in the interview, they make a bad impression about the institute. Like, this institute sends only these kind of people. That's why what we do is, every time we send any profile, we do basic screening. At least the person, can he talk? Can he answer basic questions? Then only we use support. Any other questions? Okay. If you don't have any other questions, we will end the session here. So I just want to tell you, if you want to enroll for the course, you go to this link, e-transfer, and there will be account details, and the QR code will be there. You can scan and make the payment. Initially, to confirm your enrollment, you can pay 5K payment, and remaining fee can be paid in installment. I think our manager would inform you the schedule for the payments. Yeah, that's brief about it. Does digital design sufficient digital design material? Does digital, yeah, see, digital design material will make you expert with digital design, and will it make you expert with Verilog? No, right? It will make you expert with digital design. If I ask you tomorrow, what is D flip flop, what is T flip flop, what is SR flip flop, what is JK flip flop, implement this counter using JK flip flop, implement this clock divider using JK flip flop, that level of expertise you will have. But if I ask you to develop a Verilog code for asynchronous software, will you be able to do with this digital design expertise? No. It will make you expert with digital design. But if you are a person who is in BTech 3rd year, 4th year, and you don't have much time, you go for only digital design. Because in given time, what is that you can do, that much only you try to do. Once you are free, then you go for next level of course. Even the people who are pursuing BTech, we suggest them this way only, like 3rd year 1st semester, that is technically what, 5th semester, only do digital design. 6th semester, do only Verilog. 7th semester, only do system Verilog. 8th semester, you can do advanced UVM. That way what happens, your load got distributed. And also the positive thing is what, by the time you completed your BTech, your good amount of portion of training is completed, and you can even look for the job. This also we have flexibility. I won't tell that since you joined you finish everything in 6 months. I won't even tell you spread it over 2 years. I will even support, because one statement I told is what, we run institute to keep it aligned with the student interest, not my interest. Okay. Yeah, someone asked DFT demo video. Yeah, every video you will get. See, even today, whatever I'm doing, this video also I'll upload to the YouTube, and you will get that video. Our manager will anyway send you tomorrow this video. Okay, even for DFT demo video, you will get it. Any other questions? One thing I want to tell: if you are planning to enroll, please do not delay. Uh, Reason is, don't do it beyond Tuesday like that. Reason is, once you miss one session, right? Let's say you miss Wednesday session, you start from Thursday. The problem is you miss 4 hours. That to cover up 4 hours, you have to watch the video. Then you lose track. Next session you won't follow, because you would have thought number systems, you would have thought logic gates, you would have thought basic K-maps. The next session you will directly start off with implementing something, which you probably won't be able to follow. So hence, please, in case you are decided, you go ahead and join. Uh, that's all from my end. Yeah, we will end the session here. Thank you, everyone.